I want to present the geometry quiz review from page 146 in your book. Follow along with your either PDF copy of this page or in your book on page 146, please. The one thing that I want to point out about the directions, and watch this on your quiz, think of each segment of the diagram as part of a line. Which lines or planes contain point G and appear to fit the description? So every one of our answers has to have point G in it. And that actually isolates the number of choices that we have, so everybody should be reporting the same answers. A line that's parallel to EF. EF runs on the back left edge. Parallel to it would be the right bottom, the back left bottom edge. Parallel to it would be the right bottom edge, line GH. They told us to assume that all of these segments could be part of a line, so we'll report it as a line. Line perpendicular to EF. Since this is a dice, it's a cube. Perpendicular to EF, I have to assume is line, perpendicular to EF. Perpendicular to EF, it's got to have G in it. I was going to say BF, but it's got to have G in it. So EF must be perpendicular to GF. Number 3, a line that's skew to EF, it has to contain G. The only line that's going to be skew, it's not parallel, it's not in the same plane, would be CG. So EF is this bottom left edge, and CG is this back right edge, CG, that goes along the back side up and down. Number 4, a plane that's parallel to ADE. Well, ADE is the front face, so the parallel plane will be the back face of the die. I'm going to name that as BCG. I could also have used F in the name, but remember, to name a plane, we use exactly 3 points. So any combination of B, C, G, or F in a group of 3. When we move on, it's just naming types of angles, and I want to just remind you that when we were in section 3.1, we could name these placements, but lines weren't parallel to each other, so we didn't know if we had any congruent angles. Consecutive interiors for number 5, you should have angle 3. Consecutive is on the same side, and angle 5, as well as angle 4 and angle 6. Make sure your notations are present. You're showing the angle marking, and I can tell that you're connecting these by the word and. Number 6, alternate interiors would be angle 3 and angle 6. Alternate means they're on opposite sides of the transversal. The other alternate interior would be angle 4 and angle 5. For number 7, for corresponding angles, we have 4 pairs. Angle 1 and angle 5 correspond. Angle 2 and angle 6 correspond to each other. Angle 3 corresponds to angle 7. And angle 4 corresponds to angle 8. For problem 8, alternate interior angles, exteriors. We did the interiors. Alternate exteriors, angle 1 and angle 8. And angle 2 and angle 7. As we move forward, and again, there wasn't any congruences there, just finding things based on position. When we move into number 9 and 9, 10, and 11, we do see that we have parallel lines. I'm going to fold my paper up here so I can show my work and my answers. In number 9, I'm going to start out by finding the measure of angle 1 is going to be equal to 180 minus 138. And I'm going to say that is true based on the linear pair postulate, because if I look at linear pair postulate, 2 angles that lie in a line add to 180 degrees. So I'm using the linear pair postulate first. 180 minus 138 is going to tell me that the measure of angle 1 is 42 degrees. And then the measure of angle 2, if I've got this as 42 degrees, angle 2 and the 42 degree angle are congruent to each other because we do have parallel lines. That's going to be 42 degrees, and that's by the alternate exterior angles theorem. Now I have these in my head because the theorems go right along with the name of the angle relationship, but it's the converses that I'm going to need to check here in a minute from section 3.3. Let's see, what do we got here? The measure of angle 1 in number 10 is 123 degrees. I'm going to say that that's by the corresponding angles theorem. because the corresponding angles theorem, when we have parallel lines, say that corresponding angles are congruent. And then the measure of angle 2 is also 123, oops, that looks funny, there we go, is also 123 degrees, and we can do this by a couple different things. We can say that's by the vertical angles theorem. The vertical angles theorem came up in section 2.6, I think it was. Or it was theorem 2.6, it came up in chapter 2. Or we could name that because it's across from the 123. Or since we know the measure of angle 1 is 123, we can say that the measure of angle 2 is 123 based on the alternate interior angles theorem as well. So either of those options would be fine. Number 11. In number 11, the angle is 57 degrees next to 1. So I'm going to do the measure of angle 1 is 180 minus 57 using that linear pair postulate again. 180 minus 57 is 123 degrees. Two angles that lie on a line add to 180, or their supplements. That's what the linear pair postulate told us. And then I'm going to just say that the measure of angle 2 is also 57 degrees based on alternate interior angles, because it's the alternate interior angle with the 57 degrees that was given. I could also justify that if I put together 1 and 2, angles 1 and 2, I could justify it by consecutive interiors. Alternate interiors is the one that I just jotted down. Now moving on to number 12. These questions are about being able to use our converses. Is there enough information to show that line M is parallel to N? In number 12, I'm going to be testing to see if the consecutive interior angles converse is true. I'm jotting it down because this is what I have in question. And if it is 69 degrees plus 111 degrees should be equal to 180. And when I add those things together, you know what? It is 180. So by the consecutive interior angles converse, since this is true, line M is parallel to line N. I can state that by that converse. Number 13, I don't believe there's enough information. I don't know an angle relationship between these. These aren't corresponding. They're not alternate exterior. I'm just going to say not enough info. And when I look ahead at number 14, so I cannot conclude that M is parallel to N in that. Looking at number 14, I think I might have a transitive here. Let's see. L is parallel to M, and L is parallel to N. So by the transitive, and I'm going to look in my notes to make sure I'm naming it right here, transitive property of parallel lines, if I take out that middle man L, M is parallel to N. Number 15, cell phones use bars like the one shown. Each bar is parallel to the one directly next to it. I get the idea of transitive there. Why is the tallest bar parallel to the shortest bar? So in 15A, by the transitive property, again, transitive property of parallel lines, we can say that every other bar is going to be parallel to the next. Each bar is parallel to the previous, to the one next to it. Now in 15B, we get into an angle measure. Imagine that the left side of each bar extends infinitely as a line. If the measure of angle 1 is 58, what's the measure of angle 2? Well, these would all be corresponding. Since these bars are all parallel to each other, the measure of angle 2 has got to be 58, and that's going to be by the corresponding angles theorem. Number 16, last but not least, the diagram shows lines formed on a tennis court. 16, 4 parts here. Identify 2 pairs of parallel lines, so each pair is in a different plane. Okay, well then let's look at what the planes are here. We've got our 16. I get the idea that we've got our up-down planes. We sure do. The net is shown as a plane. I see parallel markings. I'm going to start out with parallel markings across the top and bottom of the net. Q is parallel to P. I see the markings, a double marking on each of those lines. And then when it comes to the side lines, I also see that K is parallel to M. Then they want two pairs of perpendicular lines, and I see right angle markings. Right angle markings are showing us that line K is perpendicular to N, and line M is perpendicular to N as well. And then identify two pairs of skew lines, lines that never intersect and aren't in the same plane. Let's talk about line L is skew with, let's see, line M, never going to intersect that. And another example of skew lines, how about the top of the net? Line Q is skew with line K. There's a couple of examples. I could come up with others on that one as well. And then prove that, let's see, prove that angle 1 is congruent to angle 2. Well, I'm going to do this based on the right angle markings that I see. Just an informal proof here. Since the vertical angle to angle 1 is marked right, marked 90 degrees, measure of angle 1 equals 90 by the vertical angles theorem. Since the vertical angle is marked 90 degrees, the measure of angle 1 would be 90 by the vertical angles theorem. And then let's go on here. I'm just going to kind of do a paragraph proof. And since angle 2 is a linear pair with an angle marked 90, then the measure of angle 2 is also 90. And since both measures are 90 degrees, since the measure of angle 1 and measure of angle 2 equals 90, then angle 1 is congruent to angle 2. So just an informal paragraph proof for that one. Good luck on your quiz tomorrow.